Good morning. We're here for a very special episode of the Public Works Podcast. I always like when we can get out to the field at facilities and see what's going on. We're here at a facility with the South Coast Water District, but I want to turn over to my colleague, Rick. Rick, if you could introduce yourself, talk about your role, and then where we're at, orient us for today's show.
Okay, well, thanks, Shane. Thanks for having me on this program. We're at the groundwater recovery facility. So it basically takes brackish groundwater and treats it into drinking water standards. And then we use that to serve about 12% of our customer base.
That's great. And thanks to you and your team for letting me tour this with you today. We've got some video of that after our interview. Stay tuned for that. So just tell us a little bit about your role real quick at the district, and then we'll move on to some fun stuff.
I've been the general manager for the last 8 years here. I started out in 2015 as the director of engineering. It was a great start because I got to work directly on the sewer tunnel replacement project and on the planning process of the Doheny Ocean Desalination project.
Great, thanks. Rick, if you wouldn't mind, take us back to the beginning.
Sure.
What first drew you into the water industry and then into public service? I know we have a special district here, but it's pseudo-public service. You want to talk to us a little bit about that?
I grew up in Kailua, Oahu, and it was a nice upbringing. One of the things I really remember was taking a field trip of the Honolulu Board of Water Supply and seeing the aquifer that provided the water for the million residents and businesses out there, and it was fascinating. And that was my first introduction to water. When I got into college, I still didn't know what I wanted to do. Thought maybe I could design buildings, highways, bridges, so I went down the general civil path. And as luck would have it, I attended Cal Poly Pomona. It is a state school, and back then they actually had lotteries to get your classes. And as I was in my structural series, I entered a class lottery and I didn't get it. So that would have delayed my graduation by a year. And I still remember walking the halls and looking back then, everything's on a board there, and looking at the options that I could have and still graduate on time.
Okay.
And one of the options was water resources and environmental engineering, and through the civil engineering degree as well. So I picked that, and it turned out to be the luckiest decision I've ever made. And I'll tell you more about it as we go through it.
Well, that's interesting. Your career in water could be linked back to a class lottery, it sounds like.
Correct.
You could have been a structural engineer, and now you're...
Yep, I lost the lottery, and I'm in water, and I love it.
And you won. So do you still play the lottery today, Rick?
I do.
There you go.
Yeah.
So keeping on it. All right. Sounds great. Thank you for sharing that story. And because of that, you've had a long career in water utilities. What were some of the interesting moments that shaped your leadership style?
I just read a quote from Michael Jordan just recently, and it was in the essence of failing. He had failed so much, and that's why he's successful today. And I failed a lot early on as a supervisor, and I would describe myself as a taskmaster, one of those that you probably don't want to be supervised by. And that started in my 20s, and I realized that I wasn't getting any buy-in, and then people weren't learning. The team wasn't moving in the right direction. That was one of the challenges that changed my leadership style through the years, and I tried to make sure I would never go back to that micromanaging component. And I've been very fortunate here at South Coast Water District. We have what I call 87 exceptional leaders. Oh, we have a workforce of 87 folks here, and there is no need to micromanage these folks. We're picking the best and the brightest out here, and we're training the best and the brightest, and the proof is what we do today.
Yeah, that's great. That's a good way to look at it. So you're talking about people there, but was there a specific project or a challenge?
Sure.
You talked about that realization, but as far as your experience, a project or a challenge early in your career that really defines your path? So we win the lottery, we get into it, we start working, but another experience there?
Yeah, I would say a project challenge early in my career was when I was at Anaheim. There was an opening for an engineer to work more on water conservation. And this was back in the early 2000s. And there weren't a lot of engineers signing up for that. I gave it a shot. And boy, did I stumble a lot through that. I tried to learn as much as I could. I went to every possible certification class. And then through that, I got to meet a lot of NGOs, a lot of folks that are basically our checks and balances for projects. And that was one of the biggest blessings of going through that conservation supervision. The other interesting part that I learned was California is in a constant drought. So having that background in conservation really helped my career and view things in a different light.
Interesting. So the NGOs in California, non-governmental organizations,
Correct.
really the regulators of many things and pretty much everything we do in California, protect the environment, protect the people, that watchful eye. But to do all that comes into your purview as the general manager. And as the general manager of South Coast Water District, how do you define your role as the primary leader of the district? And you said you have 87 leaders, but there are other things that you obviously have to do to represent the district. You want to talk about that a little bit?
Yep. So here at South Coast Water District, as a general manager, I see my role as the person in the back of the canoe who's steering the boat in the right direction. As I said before, we have 87 leaders and we have the best and the brightest. So steering them in the right direction isn't that difficult, but we do face difficult challenges every day. Being here right next to the coast presents significant challenges, from environmental stewardship to corrosion you have to deal with your infrastructure and a whole bunch more. You saw the brackish groundwater facility. I say that brackish groundwater basin behaves like an underground bay delta with a saline pulse. Salt water moving in and out, and balancing that is another challenge that we have on the coast here. So leadership on a coastal utility provides inherent challenges. We have a great team here. I think my background here has been helpful because I volunteered for every challenge along the way in terms of learning different aspects of the utility. I was very fortunate, and it really took a village to build me as a leader. And I feel that prepared me, and I paid my dues and made sure that I was prepared for this position when I got it.
Yes, that's good observations. You mentioned some of the challenges, districts, coastal. What are some of the biggest leadership challenges facing water districts like South Coast Water District today?
Sure. What I see is we have a mix of generations in the workplace. That's a great thing overall. It's a great thing because anytime you're solving a problem, which utilities do on a daily basis, having the different generations in there contributing different feedback really leads to a better solution to the problem.
Sure.
But also the part of the challenge is all of us now are learning in what I call YouTube 5-minute videos.
Yeah, video medium. That's what we're doing today.
That's exactly right. And so my vision for the utility, it has to do with succession planning and operating manuals. Operating manuals will always be there. You're always going to have a 400-page manual on the shelf that you refer to. But if you really need to learn something, we need to get up to modern day times. And that is part of my vision, that every facility will have a 5-10 minute video on how to maintain widget A or facility B. And that is a challenge in front of us. It's going to help us with asset management, and it's going to help us with operations in the future as well.
Sure. And in California, Southern California, sometimes we have lengthy commutes.
Yes.
So that's something that an employee could put on their way to and from work and listen to what they're supposed to be learning that day or get refreshed.
Exactly.
Good idea. And as the general manager, you're trying to balance that workforce development. But on the infrastructure side, how do you balance the long-term planning with the immediate operational needs? Kind of like we saw as we went through this facility today. You've got things that are looking ahead and things that are happening now.
Yeah, it's a great question. And it also relates to finances. So setting rates, you need to fund both your operational side and the new infrastructure that you're building. At South Coast Water District here, we face that with the ocean water desalination project. It's a large investment for this district. Our sewer tunnel rehabilitation project will provide safe transport of the sewage for another 75 to 100 years, but it costs us $100 million to build. So I attribute the fact that our board had made proper decisions in the past, and it's one of the advantages to having a water district where the water district board individuals are usually keyed in on projects that need to be built. And because of that, we're not stuck trying to play catch up today. So that's been very helpful.
Yeah, I think that's a good observation. Everybody wants to be able to turn on the tap and have quality water come out to drink, right? As we take a drink. But people don't always understand that can be millions of dollars, multi-millions of dollars in investment just to have that happen every time the way you want it.
Yeah.
Right? So I think that's important that you all are highlighting that. You mentioned desal a little bit in that response. And when we say desal, it's also desalination. That is a big thing being discussed in Southern California in areas where we're in a constant drought, as you said.
Correct.
Colorado River system is overtaxed, and so we're looking for alternatives there. For South Coast Water District, you've been a local leader in desalination, or at least that discussion or that evaluation. What sparked that decision to potentially go down that path, or at least evaluate it further?
It took a village to build this project, and it all started with the Municipal Water District of Orange County. Okay. And they assembled a number of interested agencies, and they drilled a pilot slant well. And that was one of the technologies that's recognized by the environmental community and the regulators as a preferred technology. So they embarked on that study and ran the slant well for a while, and it performed successfully. And then at a point in time at around 2014, we realized that someone needed to lead this effort moving forward. Because the Doheny State Beach, where the slant wells would be drilled, and the treatment plant would need to be in close proximity, it made sense for South Coast Water District to take that lead. We had a pioneering board and a general manager, actually Andy Brunhart, who took on this project for MODOC. And that was one of the first projects handed to me when I started here in 2015. The Ocean Desalination Project was a very important part of this board's history. One of the major decisions that the board made following taking control of this project, or taking the leadership of the project, was what size of a project needed to be built. And we could have easily gone the path of building a 2 million gallon per day project, standalone for South Coast Water District, but we realized the economies of scale were at the 5 million gallon per day level. So that's what brought in the South County need this project. And if so, would it make sense for us to build a larger project, a 5 million gallon per day project to start off with, and have local partners as well?
Okay, that's interesting. Especially in Southern California, it seems like partnership is a big thing, with many special districts working with municipalities, all of that. Mm-hmm. People can live in one city but get their water from another district.
Correct.
Partnership's a big part of that. Could you also just explain for the listeners a little bit what the slant well concept is?
Sure.
Just so they understand how that works. We're inland a little bit, but desalination comes from seawater. So how does that slant well work?
One of the primary objectives for our board was to be an environmental steward in implementing this project. Part of that is the slant wells. So the slant wells are drilled about 1,000 feet deep into the ocean at an angle of about 10 to 12 degrees. It never breaches the surface, so it causes no marine life harm. On top of that, the district looked into a commingled ocean water brine discharge. So if we're producing 5 million gallons per day of drinking water, we're pulling in roughly 10 million gallons per day. So about 50% of that is screened out as brine, 50% is product water. That brine commingling in an existing wastewater outfall is also the preferred technology endorsed by the regulatory and the environmental community. So our board selected that path as well. And we've recently found out that the impact to the marine life of commingling that brine is de minimis to the marine life environment. So those two aspects were very important to our board to implement.
Yeah, thank you for explaining that. Some might think that desalination is just putting a big straw into the ocean, but you're talking about the slant well, which people think of a well as being vertical, but this is on a slant, obviously. So the well slants on an angle, as you said, below the bottom of the seafloor, so it never interacts with the fish and wildlife and all that stuff. So that's interesting. Other projects have done that too. So not the first time you're trying that, but could you also explain what some of the biggest hurdles might have been for that? You mentioned financial, always a hurdle. But what about technical or regulatory and the opportunities to advance a project like that?
So the financial hurdle is real, and I'll expand a bit on that. And you asked me, Shane, about the balancing the operations and the infrastructure costs in a utility. It all boils down to average rate increase to an average homeowner here. And that was one of the major challenges in front of us. And we thought the only way we could get a real answer from our community, believe it or not, right in the midst of the pandemic, so this was in May of 2020, our board decided to do a customer survey. So we hired FM3 to survey a number of customers, and they educated them about the project on the surface and received a favor rating of over 78% roughly.
Oh, wow.
And after that, they issued critical statements, and critical statements such as, isn't South Coast Water District being insensitive by implementing a project that would cost a bit more on your water bill while we're in the midst of this pandemic. So even those type of hard-hitting questions were asked, and that favor rating only dropped down to roughly 70%. So our board and I knew that our public still wanted this project to move forward. That was one challenge that we faced. We also asked in that survey, what were they willing to pay? And so we knew that their sweet spot was roughly in that $5 to $7 range. And you hear that a lot with the Delta Fix and other projects. That's usually the point that folks are comfortable investing in a water project that brings them more reliability. In terms of technical challenges, it was more the permitting, as you can imagine. Sure. And permitting is done by doing all of your pre-permitting work. And I know you're a sports guy, Shane. So all of the workout you do prior to the game is what really counts. And that's what we did. And we talked to many folks. Our communications team really helped us through this as well. A lot of the stakeholders that we don't necessarily correspond with on a day-to-day basis needed to be brought into the process, such as the tribes, such as the NGOs that have expanded and have produced a lot of feedback on these types of projects. And so what we did was we met them head on and really discussed and just put the facts on the table. They gave us feedback through the process, and it really helped carve a better project at the end of the day. I really believe that.
Wow, that's great. And at that high of I'll just call it like an approval rating or percentage, even if things go sideways a little bit, like they might do with a project, you've still got some room in there that people understand the broader vision. And one last question on that project, and I'm a big fan also of alternate delivery methods. I think that project is being run as a design build or progressive design build. Is that
correct.
Right?
Progressive design build operate, correct.
That's great. Progressive design build operate.
Correct.
Okay, very good. Thank you. So people might want to reach out to you if they want to hear more about that with your team, because that's an interesting point. Now you've brought all that, and that's given you a great career and the ability to provide advice maybe and some reflection, and you did some of that on your own, as you said. But what advice would you give to young professionals considering a career in public works or water utilities, or the pathway maybe that you went on?
Sure. Right or wrong, the way I describe utility service is our operations are front and center. The rest of us, including myself, are support services to the operations team out there. So the one recommendation I would make is get involved in some shape or form in water operations if you want a career in water. And I was very fortunate. I was not in the operations group in Anaheim, but I got to meet one of the best operations managers ever, Rich Mathis. And Rich Mathis took me under his wing and taught me quite a bit. And I had the privilege of working with our treatment operators as well, and developing plans for them and interacting and understanding the processes more. And I wish I'd done that more. Yes, that would have helped me in my career and helped me understand quite a bit more. So I would emphasize, get involved in some shape or form with operations. The other advice I would give is volunteer for the work that you don't typically do. If you're an engineer, I mentioned conservation, you want to learn as much as you can about the utility before you start moving up in the ranks. And part of that is because utilities service touch on customer service, finance, operations, engineering, you name it, conservation, recycled water in our case. We actually run the Joint Regional Water Supply Pipeline, which essentially serves metropolitan water from the Irvine area to the north side of Camp Pendleton. There's so many things you can learn in this industry. And I really want to tell folks that's the most important thing to do, is volunteer for as many projects, different projects that you typically wouldn't do.
Interesting. So get a breadth of experience. Also try to dig in and learn about the operations. That's a heartbeat of many organizations. And perhaps of your 87 employees, if you looked at that from a percentage standpoint, what do you think the amount of that workforce is boots on the ground operations versus support?
So it's roughly 50-50.
Roughly 50-50. So half the organization is out making it happen.
Correct.
And I think as organizations get bigger, I know when I was at the county, it was a pretty healthy percentage more boots on the ground than support. Those are the people doing all the work. And I like your point about trying to support them, everybody else trying to help them be successful, because they're out working with constituents, they're providing service to ratepayers.
That's right.
They're out making sure the water line's working or whatever the case might be. I appreciate that. So that's advice for other people, but how about some advice for yourself? So if you could go back and give your younger self a piece of advice, and you talked about this a little bit earlier, but what do you think that might be?
There's a lot. There's a lot I could have
done. How much battery do we have left?
Yeah.
You mentioned you didn't really appreciate the micromanagement piece as you look back, but there could be other things you were interested in.
Correct. Shane, I thought about this, and when I was younger in high school, the only thing I ever wanted to do was be a pilot. And that's all I wanted to do. The path didn't take fruition, and I had my dad who actually guided me into civil engineering. He said, who knows you better than your dad? You probably fit in as a civil engineer. So why don't you try that path? See if you like it. If you don't like it, you can try something else. Yeah. So that's part of it, listening to some of these folks that really have your best interest at heart. I think finding your mentors, whether they're family or friends, is very important. And that's something I think as my younger self, I didn't want to take everybody's feedback at that point, but I think it's really important to do that. And it really helps you find your path. And for me, it was a little bit accidental in the water field, but boy, it's been a really nice journey.
That's great advice. People younger in their career, try to reach out, maybe mentors or whatever, try to listen a little bit. Maybe you could talk to my teenage boys about that, listening. But I did like what you said about civil engineering for maybe options. And I always think about engineering, that profession, as being a professional problem solver.
Correct.
You can go in many different directions if you have a foundation of engineering, in my opinion. Yeah. I think that's good. Are you open to a couple of quick hitters, little rapid fire questions here to wrap us up? If you had to choose one word or words to describe the future of water in Southern California, what would that be? Okay,
I got 3 words. It's in good hands. So it's in good hands.
In good hands.
And the reason why I say that is everybody talks about water and the challenges that we have in California. And how could we possibly solve this problem? Well, I think we really have the best and brightest in this industry. We have people that are passionate about water. And that's what you're going to find in the water community. If people are passionate, they love trying to solve this water problem. I have faith that it will be in good hands for many decades.
That's great. That's comforting also, which is great. So that might lead into this quick hitter. What's the most rewarding part of your job?
The most rewarding part of my job is people. The people here at this district are phenomenal. And it's the staff, the board members, even the community. Whenever we're going up against each other for certain issues, they just have their best at heart as well. They want to make sure that we're providing the level of service and we're being fair and equitable to all of them. Who would ask for anything else? So the people I get to work with day in, day out are the most important thing to me. And I'll tell you a quick story. When my mom was having health problems, and everyone's in Hawaii, I'm the one who came out here. I went back and took her to her appointments, and I told my mom, this was when I was assistant general manager here, that, hey, let me move back. I'll help you guys out. I'll find a job here. And she said, why would you do that? And I said, well, what do you mean? And she said, you always talk so fondly about the folks here at South Coast Water District. Why would you want to change your career? Because that's hard to find. And my mom, being a 40-year public school teacher, has a lot of good perspective. And that's good feedback that I really took to heart. And I stayed out here, and I'm glad I did. And the people here, she's right, are really tough to find. So I'm in a good place.
That's great. I appreciate that. Again, listening, right? That's a good thing for you, just listening. That's great. So for our listeners here tuning in, what should everyone know, or what's one thing everyone should know about South Coast Water District? They have great people. Yeah. We know that. Anything else you wanted to mention?
On the operations side, they've taken it seriously. And I've told you from the board perspective, and what they've approved in the past has been very significant. The passion and the expertise they bring to the job are second to none. And proof are in the key performance indicators that we see. And I could just rattle off a few. First one, the Joint Regional Water Supply System. That's an enormous responsibility. It's essentially a miniature version of Metropolitan. It's large diameter pipelines, 2 large reservoirs, and the experts that we have, and there are roughly 6 operators that are operating that entire system, and their abilities are, and the performance indicators reflect that they're running it at the highest possible level. So I couldn't be prouder to be associated with that. Our water system is about as tight as they come in a good way. And our water leak levels are one of the best in California. That doesn't happen by accident. That happens with good decisions that are made in the field and good implementation that's made in our engineering department through these projects and board decisions as well. And on sanitary operations, our sewer collection service system, we have one of the best infiltration and inflow rates, or the best infiltration and inflow rates around the region. And that doesn't come by accident either.
Sure.
Their maintenance schedules in terms of cleaning and lining pipes are at a very high level, much higher than we see throughout the state. And that, again, is part of good, healthy decision making by our board. And we're also looking at the bottom line and making sure those decisions are cost effective. So you'll see we've made a lot of consequence of failure type analysis here on our systems to ensure that we're paying attention to the correct areas and we're not just overdoing it in terms of rehab and replacement.
That's great. So that thing everyone should know then is the teams are doing a great job. They're highly effective, high performance. You have the metrics to back that up.
Mm-hmm.
So that's great. That's awesome for you and the team. Well, Rick, I appreciate the time today for you and your staff interesting here at this facility to get that tour. If listeners want to learn more about South Coast Water District and the work that you and your team are doing here, what should they do or where should they go to find out about that?
There's several places they can go. They can go to SCWD.org, our website. We're also very active in social media. The listeners can see us on Instagram, Facebook, and LinkedIn, along with our website at scwd.org. We have project updates on the ocean water desalination project on there, if you're interested as well. Thank you.
That's great, Rick. And so that was Rick Shintaku, the General Manager of South Coast Water District. Thanks everybody for tuning in today for that. And this episode of the Public Works Podcast has the interview, but also has some video afterwards of the tour of this facility. So please stay tuned for that. Thank you again, Rick, to you and your team.
Thank you, Shane,
for your time today.
Thank you. I really appreciate it.
Okay. See you next time.
I'm Steve Dishon, Water Resources and Treatment Manager with South Coast Water District, and we're here in Dana Point at our groundwater recovery facility. My background, I've been in the industry for 36 years, been with the district for 18 years, and primarily doing treatment my whole career. And we're going to go through this facility. This is a brackish groundwater facility, so we pull unusable groundwater and we convert it into drinking water and pump it into our distribution system.
Great. Okay, Steve, what are we seeing here today?
This is our Stonehill Well. The Stonehill Well, it's a shallow well, only 126 feet deep. It pulls water from a subterranean stream that's considered part of the San Juan Basin Authority. The water is very high in chlorides, salts, a lot of different minerals. It is undrinkable out of the ground with a total dissolved solids of 2,700. Very high iron and manganese levels. The water's pumped out of the ground, goes through a sand separator. We get almost no sanding, which is a good thing. Goes through a flow meter. We measure it for turbidity, and then it gets diverted into two places in our treatment facility. About 87% of the water goes through reverse osmosis. The other 13% goes through iron and manganese removal, and then they combine back together again. And the reason why we do that is because the reverse osmosis removes all of the minerals, and the water's about at 5.5 pH, is pretty much aggressive at that point. So we need to get a small amount of the minerals back into the water again. But because our iron and manganese levels are so high, we do have to pass that bypass flow through an iron and manganese removal process. They come back together again, and then we add disinfection chemicals, small amount of pH adjustment, and then it goes out into our distribution system. But this is the first step, is the groundwater well.
Okay, Steve, what are we looking at now?
This is our pretreatment area ahead of the RO system. The raw water comes in, it goes through cartridge filters. They're 5 micron nominal cartridge filters. They are 40 inches long, and there's 103 of them in each of the vessels. The purpose of those are to keep any particles larger than 5 microns out of the reverse osmosis system. It's also where we add our pretreatment chemical, basically called the threshold inhibitor, which keeps minerals in solution so they don't precipitate out onto the membranes. It's the first place that we look at our water too. We have a water quality board over there where we're looking at turbidity, pH, conductivity, temperature, and we also have a flow meter for our threshold inhibitor because the pre-treatment chemical is so critical that we have to make sure that flow is occurring. So we have a verification for that. And that's this board. You can see that we have it trying to protect it from the sun as much as possible. We also have pressure transducers there as well for measuring our pressure in and out of the cartridge filters. From here it goes into the ground and it comes up inside the building where the reverse osmosis system is.
Okay, Steve, we made it inside now. What's happening in here?
This is the reverse osmosis system. The pipe from the pretreatment area actually comes up over here, goes into a high pressure booster. Can't see it because we have it surrounded with sound dampening boards, but there's a high pressure booster there. The pressure runs between 160 and could go as high as 250. It pumps into the reverse osmosis system. 18 of these vessels are live. We do have some vessels available for expansion. Like these vessels you can see are empty, but 18 of the vessels are live. There's 7 membranes, 40 inches long in each vessel. So there's 147 membranes total in the system. The way that reverse osmosis works is it's not a situation where the water goes through all these into the center tube. Actually, what these are envelopes, and the way to picture it is this center tube, there's envelopes that are sealed on 3 sides, and there's 47 of them, and those 47, both sides of that sheet have the permeable membrane on them. So that whole assembly gets rolled up very tightly. So as the water's coming into these channels, these feed spacers let the water pass through, and then it goes through the membrane, traveling all the way back to this center tube. Each one of these 40-inch membranes has 400 square feet of filtration surface. So that's how we're able to do so much water in this small of an area, is because they're able to pack a lot of membrane into a small area. And then again, there's 7 40-inch membranes in each vessel.
So we're looking at what's actually inside those tubes.
Yeah.
Yeah. Okay. Nice.
They're not cut away.
Exactly. Okay, Steve, we moved outside now. What are we looking at here after the reverse osmosis?
So like I mentioned earlier, the reverse osmosis removes all the minerals, and the pure water basically becomes aggressive at that point. If we were to put that water straight out into our distribution system, it would rob the metals out of the pipes. So what we do is we take some of the flow and we bypass the RO system. Well, since our water is so high in iron and manganese, we run the water through an iron and manganese removal system. So basically the way the iron and manganese removal system works is we chlorinate the water to oxidize it. It runs through a green sand, a special type of media, which removes the iron and manganese. And then when it comes out, it's the same water less the iron and manganese. And then it goes underground and blends with the reverse osmosis permeate, the filtered water from the reverse osmosis, and it goes into that decarbonator. Now the decarbonator is basically a large tank with packing balls, and we blow air up through it. And the purpose of it was, when the plant was first built, part of our pretreatment was sulfuric acid, and this would help to remove some of the CO2 before it went into the final clear well. But we're not using the sulfuric acid anymore, so really the decarbonator isn't really doing much. Okay. On the back side of the decarbonator, there is a mixer. We can walk over there. There's a chemical mixer where we add a very small amount of sodium hydroxide or caustic to raise the pH a little bit more. And then we add chlorine and ammonia to make chloramines. And those go into the clear well. Now this is a 16,000 gallon clear well that goes down about 14 feet. There's about a 30-minute detention time in the clear well. We're measuring our water quality again at this board, and then we boost the water with these pumps out into our distribution system. And basically there's 3 places the water can go. We have a wholesale line because the district operates the Joint Regional Water Supply System, which we almost never go into. We have our 391 zone, which is the South Coast zone, which is this whole area up here, and there's a reservoir actually on the top of that hill, and the water basically floats off that. And then we have our run to waste, basically goes to our outfall. So when we're first starting the plant, before all the residuals have settled down and everything's perfect, we can run to waste, and then when all the parameters are where they need to be, we can divert the water into our distribution system.
Okay, Steve, wrapping us up, we've got to the end, so these pipes go into the ground, but then what happens? It's groundwater, yes, but what's the radius of that, and then where are we at geographically?
So the water goes into basically southeast Dana Point. Most of it is consumed before it even gets to our reservoir. We do have a 2 million gallon reservoir that floats off this system. When we have many days of rain in a row, the demand goes down and the water actually makes it to the reservoir. But for the most part, it's consumed by the residents in the area of southeast Dana Point.
Great. Thank you, Steve. Appreciate your efforts. So, Steve, we've moved from all the pipes and gears and machinery into the office setting where probably the brains are of this operation. Tell us what we're looking at here.
So we have our motor control center with our variable frequency drives to control the pump speeds, and basically all the electronics come into this room. There's also a SCADA system in there, which is a remote system that we use to monitor the treatment facility. And all the parameters for the plant all have a warning alarm and then a shutdown alarm. So if any of the residuals or pressures or water quality parameters go outside of their normal area, it'll first give us a warning, and it will call out an operator, and an operator will be dispatched to figure out what's going on. Or if it goes too far, it'll actually kill the plant, and then the operator has to come out, figure out what happened, fix it, and put the plant back online again.
Steve, real quick,
Sure.
for our listeners, SCADA is an acronym for what?
I was afraid you were going to ask me that.
Security, Communications, and Data Acquisition.
There you go. Thank you. But there is somebody on duty 365 days a year, 24 hours a day. Christmas Day, I've been out here a couple of different times in my career, but that's the way the plant is monitored after hours.
Great. And then this graphic here, obviously it's just a graphic user interface, but this is showing basically what we saw in real life in the field. It's representing it now graphically so the operators can see if there's an issue or what might be going on positively or negatively.
Exactly. And there are sub-screens that show every part of this. This is an overview of everything, but there are additional screens that show specifically what's going on with each chemical, each water quality board, everything that's in the facility.
Good job, Steve. All right. Here we are.
Joseph here, Public Works Podcast.
Shane here as well.
All right, so you just watched some cool content. All we need from you is to hit the like button, hit the subscribe button. It helps us get the message out. It helps us propagate the gospel of Public Works. So if you have free time, which you probably have 2 or 3 seconds, hit that like button, hit that subscribe button so more people can follow us.
That's right. All we're trying to do is highlight the public works industry.
That's it.
Make those professionals trying to improve your communities look good and raise awareness and credibility of public works.
Yes.
It's easy to do.
Once again, thanks for watching. If you have any content ideas, if you have any questions, please put them in the comments. and Shane or I will answer them within a week of you putting it in there, and we'll get you the answer that you need.
Thank you very much.